Welcome to MRU E-Learning, powered by Maladi University. So myself, Dr. R. Nagaraju, working as a professor in the Department of Computer Science and Engineering, AML, School of Engineering, Maladi University. So today's e-learning topic is Introduction to Machine Learning and Supervised Learning Algorithms. So coming to introduction part of machine learning. So first one is what exactly the learning. So learning is any process by which a system improves performance from the experience. So it is going to be represented by three tuples, P, T, E. So what exactly P is? So in order to improve the performance of a specific task, and the task is represented by T, and with the previous experience, that is element is E. So well define the particular learning task always represented by P, T, E. And coming to the machine learning general definition, if you consider, it is a field of study that gives computers the ability to learn without being explicitly programmed. And coming to the components of machine learning. So there are three components which we have just now familiar about, three tuples, that is T, P, E. Here we will look into it with respect to the examples. If you consider a specific task, the symbol which is going to be represented by T, and the definition is it is a specific activity the system must perform. And coming to the example, whenever you are representing classifying the email, whether the email is a spam or not. And coming to the performance, so here we have to consider one more element, that is performance. It is nothing but one kind of metric. It is used to evaluate how well the system accomplishes the task. And here the example, with respect to the example, if we can able to represent the percentage of emails correctly classified as per the requirement. And coming to the experience, it is an existing data we are going to be consider in order to represent this particular email spam. So here, if you consider the complete data set from the previous emails, what we have retrieved. So these are the three major components we are going to be consider. And coming to the next, what exactly the functional components in order to build a particular model in the machine learning. So basically in the machine learning algorithm, it is going to be translated into three kind of topics. That is nothing but first one is representation, evaluation, and optimization. Coming to the representation, this component defines what the model looks like and what exactly this particular learner is going to be representing from this particular given data set. So here what exactly does is it's going to be map input data to output prediction. So what exactly the input data we have received from the data set and what exactly the expected outcome. So that kind of prediction we are going to be representing as a part of representation component in order to build a particular machine learning model. And example you can able to consider decision trees, neural networks, linear regression, and also several classification techniques we can able to consider in this representation element. If you consider the decision tree, it is going to be represent a set of rules as a flowchart. Example, if a word is free or present or classifying a specific word is spam or not. So in order to represent this kind of way, we are going to be use this decision trees. And neural networks also we are going to be having a different patterns representation in order to represent in artificial neurons. And coming to the linear regression, in this case, we are going to be represent the relationships among the particular input as well as output elements. And always it's going to be representing in the straight line format. And the general equation we are going to be representing y is equal to mx plus b. And here coming to the next one is evaluation, one more parameter. In the evaluation, always we are going to be representing what exactly the error rate and what exactly correctness of that particular outcome. And this component is going to be representing how we distinguish good model from a bad ones. And here we are going to be consider the examples. For example, mean square error. It is generally used for regression and in order to predicting house price. And coming to the cross entropy or else loss regression, it is used for classification point of view to predicting whether a particular object, a cat or dog or any specific object. So for that particular point of view, we'll use this evaluation. And one more parameter also we can able to consider accuracy. So finally, all these we are considering in order to represent the final accuracy as per the required or not. And coming to the next one is optimization. So this is one more element which defines how the model improves. And also we are going to be representing a model structure and evaluation. Okay. So in between these two, we are going to be considering how it is connected, how this particular model is connected with evaluation. So through that we are going to be finding whether optimization, what exactly the more optimization is required or less optimization is required as per the model representation. And it is going to be represent systematically updates the model to find the best version. So whenever we are going to be build the model, there will be several versions will be representing. Out of that, which version is the best one, that we are going to be representing, and the final version we are going to be taking into consideration where we are having optimized error, optimized range. So that is the main objective of this particular optimization. So with respect to this one, we are also having several examples: gradient descent and greedy search, evolutionary algorithms. So different ways we can able to apply this particular optimization techniques. And coming to the next one is, if you consider the summary among these three components, the first one is experience and representation and evaluation. So whenever we are considering building a particular model, so data which we are fetching from the existing one and how we are going to be representing in order to build a model, so there will be some connectivity. And after that, the model makes the prediction on a particular task, whether as per the requirement the model was built or not, we are going to be observed. Then after that, we are going to be see that evaluation parameter. So this evaluation parameter always which represent a loss function. So whenever we are getting that loss function, always it leads to 0. That will be the best solution we will consider. So based upon our requirement, we will try to reduce the loss function. So accordingly, we will take that final version as a best outcome for the suitable model. So coming to the next one is how we are going to be representing the difference between traditional programming and machine learning programming. In the present era, there are two kind of programmings. In the traditional programming, if you consider, generally a computer which consider that a data as well as programming, we are expecting the outcome. So example, you can consider Java programming, C programming, C++ programming. So all these, always we are expecting the outcome after giving program to the system, and then after that, whenever you are executing the program, you are giving some inputs. So finally, you are expecting the output. So that is traditional programming approach. And coming to the machine learning programming, it's not like that way. So in the machine learning programming, we are going to be give data in the form of data sets, and also we are going to be representing the output, what exactly the outcome is supposed to be get generated. We are going to be giving the final expected one in the form of model. Is nothing but here in the machine learning, the particular machine learning approach is responsible for generating the model as per the requirement, and we no need to worry about what exactly the internal logic required to represent. So this is the major difference between your traditional programming and machine learning programming. And coming to the next one, what exactly the features we can able to consider in order to differentiate traditional programming as well as machine learning programming. The following features we are going to be represent. First one is what exactly the kind of input we are going to be take, and next one is output, how we are going to be consider, and development, focus, maintainability as well as interpretability. So these are the 5 major features we are going to be use in order to distinguish traditional programming as well as machine learning programming. In the traditional programming, some set of rules plus data we are going to be consider, and in the machine learning, what exactly the data is nothing but data set followed by what kind of output we supposed to be take. So these are we are going to be considering as an input parameter. Output is in the traditional programming, we are getting the outcome in the form of answers, is nothing but expected output you are getting or not. And in this case, a model building. Finally, the outcome always representing a model in the machine learning approach. And next one is the development focus. So we are going to be representing writing a code or specific logic that we have to give to that particular machine in order to get expected outcome. And in the machine learning, we are going to be representing tuning the model, how it has to be represent all these things, the set of elements and set of processes, we are going to set of step-by-step process, we are representing in this particular development focus. And next one is maintainability. It is some complexity grows in this traditional approach, but in the machine learning, it is easier to update. Is there any further updations are required as per the requirement? Next one is interpretability. In the interpretability is you can the reading code as well as observing and giving, it will be taking more. And in the interpretability point of view with respect to the machine learning, it is very low compared to traditional programming. And coming to the next topic, what exactly the concept of machine learning and how it was evolved, from where it was evolved. The first one is basically the major and main component is artificial intelligence. So it is the first concept where they were introduced in the year of 1950s. Later from there, one subdomain is machine learning, and again one more domain is deep learning, like that, so on, extending till now. And coming to the artificial intelligence, if you consider, it is the ability of a machine to imitate human intelligence. This is generally artificial intelligence. By using the artificial intelligence, we can able to perform any kind of task in any kind of manner as per our requirement. And coming to the machine learning, it's a part of or else a subtopic of your artificial intelligence. And here, algorithms to incorporate intelligence into machine by automatically learning from the data is nothing but from the data you are going to be learning, and you are making a machine to do a specific task in order to predict, in order to take a specific or in order to perform a specific task as per the requirement or to build a specific model. So that is the main objective of machine learning. Coming to the deep learning, here we are going to be mimic human brain to incorporate intelligence into machine. Is nothing but some kind of neurons as well as some specific more internal way. If you want to go more in depth, we are going to use deep learning. For example, if you consider deep learning point of view, if you are considering a fruits, for example, you want to represent whether a particular fruit is apple or pineapple, so that classification as well as identification will be done by the machine learning, but you cannot able to represent how long it was existed and what is the lifetime of the fruit. So in order to represent the lifetime of a fruit and how long it was existed, that kind of analysis we can able to perform by using deep learning. So this is the basic difference between your machine learning as well as deep learning. And the next one is the types of machine learning. So in this case, there are the following categories are represented as representing here. The first one is supervised learning and unsupervised learning and semi-supervised learning and reinforcement learning. Coming to the supervised learning, here we are going to be representing a model which learns from the labeled data. And here it maps always the input features to the target outputs. That is the main objective of this particular supervised learning. And what exactly the training data we are going to use? Input features as well as the output label, which we are representing with X as well as Y accordingly. And the main task of this one is prediction as well as classification. In the supervised learning, we are going to be predict a specific outcome as per a given input features, or else we are going to be classify the data which we are obtaining through the data set. And examples we can take several, like predicting the house price and predicting the stock price, as well as we can also classify several objects as per the requirements. So this is the introduction part of your supervised learning. Coming to the unsupervised learning, here in this model there is no label data. So without having any label is called with unlabeled data, we are going to be finding a specific patterns as well as structures as per the requirement. And if you consider this particular training data, always the training data will be represented input features only. There is no corresponding output label. We are not going to be representing any output label, but if you consider that what exactly the task is supposed to be performed is, so we are going to be take several different tasks like clustering and association, dimension alter reduction. So all these several tasks are associated to represent unsupervised learning. And coming to the example, so grouping customers into market segmentation is called clustering, as well as reducing the number of features is nothing but a principal component analysis. So this is one kind of examples we can able to represent with respect to unsupervised learning. And coming to the semi-supervised learning, it's in a combination of about two, supervised as well as unsupervised learning, and mostly unlabeled data with a small subset of labeled data. And in this case, the main task of this particular semi-supervised learning is it improves model performance when labeled data is experienced with time consuming. And here in this case, the particular example we can consider training a photo classification with a few labeled images and a few unlabeled images. So here in this case, whenever your data is combined with labeled as well as unlabeled data, so where we are going to be using this semi-supervised learning technique. And coming to the reinforcement learning. So in the reinforcement learning, in this case, the model always which represent as an agent which learns to make sequence of decisions in an environment to maximize cumulative reward through a specific trial or error base is nothing but, for example, if you are playing a chess. So whenever you are playing a chess, for each movement, that particular movement, you have to generate a reward, either plus or minus. Okay, so that kind of manner we are going to be represent through this reinforcement learning. And in this case, no predetermined data set, and the agent interact with an environment to receive reward or penalty. Okay, so here in this case, for every specific task, either you are going to be rewarded or else penalty. Is nothing but reward means plus and penalty means minus. So in this manner we are going to be represent. So the main core task of this reinforcement learning is optimal decision making or controlling the particular data. So this is regarding different types of machine learning. So now let us move to our supervised learning concept. So as per earlier we have discussed, the supervised learning, always the data which we are having labeled, and also we are going to be give some input data as well as we are expecting or else we are predicting outcome with labeled data. And in this case, the main core type of machine learning is always this particular algorithm learns from a training data set that is already labeled, and which means the input data is paired with correct output data in the case of supervised learning process. And here if you consider the equation, so always x is an input variable and y is an predicted output variable. So general that particular equation, whenever we are representing in the regression point of view for supervised learning, y is equal to f of x. And coming to the next one, what are the different types of supervised learnings are there? There are two categories falls under supervised learning. The first one is regression, next one is classification. So in this case, regression always the output variable, either it is a real or continuation numerical values. Like basically we are going to be consider predict a continuation quantity. Example, if you take predicting selling price of an house based upon the size and locality and some other amenities which they are providing. And also we can able to predict the temperature, we can also predict the stock price prediction. So all this comes under prediction. And coming to the classification, this particular classification, the output variable is a categorical or else a discrete value. Is nothing but whenever you are representing the output variable, either it will be yes or no, or true or false. Like whenever you are sending a mail, we got a particular mail into our mailbox, we are going to be finding whether the mail is spam or not. And whenever you are going to be find an object, there is some image you found. What kind of image? Whether it is you want to classify dog or cat. So in this manner, we are going to be use this classification technique. So coming to the next one is what exactly the types of regression algorithms and how it will vary with respect to examples. So that we are going to be looking into this particular slide. So first one is simple linear regression. In this case, the models, it going to be models the relationship between your independent input variables as well as a dependent output variable. So the equation which can able to represent y is equal to some b0 plus b1x plus epsilon. And coming to the example, as we already discussed in the previous slide, like is nothing but you are going to be predicting house price prediction and some stock price prediction. So in this case, we have given the predicting a student's test score based upon his performed and how many hours he studied and how better way he performed. Accordingly, we are going to be predicting what exactly the outcome of a particular student test. And coming to the multiple linear regression, in this case, two or more or multiple independent input variables will be used in order to get one outcome. But here in this case, always we are going to be used for predicting the outcome only. But the equation which falls under multiple ways, b0 plus and what exactly b1 beta 1 plus beta 1 into x1 and plus beta 2 into x2 and so on. What exactly x? Here in this case, so if you consider this x, x1, x2, xn, all these are which are independent input variable, but outcome is only one outcome we are having. So in this case, what we are going to be use here, whenever you are having multiple options, is nothing but you are having you want to find out that house price based upon the size, number of bedrooms, and how many years old, and what kind of location. So all these things, if you want to represent, so then based upon that you want to find out the outcome, we have to use this particular multiple linear regression. And coming to the next one is polynomial regression. In the polynomial regression, it is used whenever the relationship between the independent variables as well as dependent variable is in the form of non-linear. In the previous case, both are linear, is nothing but there is a no degree representing and there is a no increment of that particular subsequent variables. But here in this case, we are going to be having some polynomial, is nothing but non-linear fashion we are going to be use. So example we are going to be take in this case, modeling a growth rate of virus over time, and which are going to be representing a non-linear or else exponential curve. And here in this case, always it is going to be representing some curve manner. So here, that's what we have taken, some polynomial, beta naught plus, and beta 1 x to the power of 1, and beta 2 x to the power of 2, and so on. You can able to use like this equation to represent polynomial regression. So basically we are going to be use whenever the growth rate, like you can also take some stock market price detection for a specific stock, because always it never be equal, never be similar, it will be growth either increasing or decreasing based upon the specific timings. So this is a polynomial regression. Coming to the regularization regression, so based upon the penalty we are going to be represent, in this case the three categories we are using, ridge regression, lasso regression, and elastic net regression. It is a one kind of a small part whenever there is a concept of penalty is occurred. So in order to reduce the penalty or in order to find out that particular penalty value, we are going to use this ridge as well as lasso regression. So in this case, always the penalty proportional to the square of magnitude and coefficient of that particular equation. And basically what exactly we are going to be use? So multi-collinearity whenever we are having, so there we are going to be representing ridge regression. And lasso regression also whenever you are adding a penalty which is proportional to the absolute value of magnitude or else coefficient. So whenever you are adding more penalty, so there we are going to be use this particular representation of lasso regression. And here majorly we are going to be use, it can representing exactly 0 or else effectively performing feature selection. And elastic net regression is a combination of both lasso as well as ridge regression. So whenever you are combining this both, what exactly the penalties? So always we are trying to reduce the penalty towards 0. That is our main objective. In order to do that particular way, we are going to be build the model. Coming to the example, let me explain some example. What exactly is predicting a particular person salary based upon their years of experience using linear regression. So far we have seen what exactly the types we are having regression techniques, that is nothing but simple linear regression, multiple linear regression, and lasso regression, ridge regression, and several categories. And out of that, let us have a discussion with respect to this particular program. So here in this case, we are finding that based upon the years of experience, what exactly the salary component need to be fixed for a particular person in a particular organization. In this case, in order to represent, if I want to represent a specific model, so the following libraries are required: NumPy, and next one is the scikit-learn linear model and scikit-learn model selection. So from there, what we are importing? We are going to be importing linear regression as well as a training and a testing, splitting for a particular required data set. So here if you take the first parameter already represented, what exactly the components we are considering from a label data. So X and Y. So what exactly X? X always we are going to be representing in the form of how many years of experience they are having, and Y component is what exactly the salary in the form of here 40, 45 is nothing but in the form of 1000, 40,000 for 1 year experience person, and 45,000 for 2 years experience, and so on. 10 years experience person, I have given 100k. So this is the maximum representation in the form of array I have given. Now I want to find out. So whenever a particular person is having some 20 years experience or 12 years experience, so what will be the predicted salary as per the existing information? And in order to find out that, the first one is the data I am going to be splitting into two categories, training as well as testing data. From there, here also I have represented very clearly. So 20% I am using for testing and remaining 80% I am using for training. So here also I have represented test to size, 0.2 is nothing but 20%, and also I am representing one function, train underscore test underscore split, which I have retrieved from scikit-learn model selection. And here in this case, how I am going to be fitting this particular data to the model, that is nothing but here model I have retrieved linear regression, already it was imported from that particular scikit-learn model, linear model, and now I am fixing training as well as testing components with respect to the model. And then after that, in the prediction, what is my prediction outcome, how many years I have given, up to 10 years I have already given. Now I want to predict for the 12th year. If the person is having 12 years experience, what will be the expected salary? What exactly the outcome? So that we are going to be representing through this particular model. And in this way, we are going to be see the outcome, what exactly outcome. So here in this case, if the person is having 12 years of experience, the expected salary is some 1,13,362 rupees. So like this, we are going to be developing a model by using a linear regression, and we are going to be take for the same example, but here what exactly we are going to be see is in the form of graphs, like what exactly, let me show what exactly the main difference I have taken is matplotlib I have taken whenever I want to represent in the form of graph model. So here I did not give it any specific input values. I have directly retrieved that particular salary underscore data.csv file. From there I am fetching the data and it is going to be analyzing, and the outcome always it is going to be representing with respect to salary and experience components. So how the data set is going to be representing for training as well as testing. So the explanation with respect to the concept is similar like same example, but here the view point of view I am going to be changing. So here we are going to be representing, how we are going to be representing the curve for this particular linear regression for training data sets and testing data sets. And coming to the classification, in the classification, the first classification technique is logistic regression. So what exactly this classification use? So basically it is used for classifying a particular from the data sets, either it is discrete or categorical class label based upon the input data, and the main goal is to determine the category or class or type a input belongs to. And coming to this particular linear model, basically that logistic regression and support vector machine comes under linear model classification technique. In this case, always we are going to find some boundary with a line or plane or hyperplane, and it's going to be separate the classes based upon that particular given inputs. And finding to the first one is logistic regression. In the logistic regression, basically that particular mechanism which we are using, sigmoid function, and here by using the sigmoid function, always the outcome is going to be classified either yes or no, true or false in the form of 0 as well as 1. Example already I have given here for classifying a specific email, either it may be spam or not spam. Not spam always represented with 0 and spam always represented with 1. And coming to the support vector machine, here we are going to be find the optimal hyperplane, and it's going to be maximize the distance between closest data points from a different classes. So here it is called support vectors, and it is also used for handle the non-linear separation using kernel trick. And in this case, basically where we are going to be use this support vector machine is image classification. There are several images, and which image belongs to which classification, which category. In that particular point of view, we are going to use support vector machine. I already given here determining if an image contains cat or dog, or other than these two any other images. So these kind of multi-class classification also we can able to perform through this support vector machine, or else binary classification also we can perform based upon a input images. And coming to the next one is tree based as well as ensemble model. Whenever you are representing tree based as well as ensemble model with respect to classification algorithm, so this model basically it is going to be representing feature space into rectangle regions, and that is generally called as decision trees. And whenever you are having some kind of robust predictions, is nothing but strong predictions you required, we are going to be represented through ensemble learning algorithm. So in this case, decision tree as well as random forest, which are purely we can able to consider tree based classification algorithm. But whenever you are using gradient boosting and bagging algorithm. So in this case, I have given gradient boosting, XZ-boost as well as light gradient boosting algorithm mechanism. So this comes under, it is an ensemble algorithm, but whenever you want to require more or else strong predictions based upon the data, we are going to be use this particular tree-based ensemble model. So examples also I have given. Whenever a role risk assessment, okay, is nothing but deciding if a customer is having high risk or low risk based upon the income, credit score and debit operations. So whenever with respect to the banking sector, we can able to use this based upon the different parameters, what exactly the risk assessment in order to issue a loan to a specific customer, that we are going to be use this decision trees. And coming to the random forest, in the medical diagnostics, generally we will apply random forest. So here in this case, predicting if a patient has a certain disease or else what kind of tumor and what kind of classification of and how it is going to be affecting with respect to the particular patient body, all these things we are going to be representing in the medical diagnostic reports, and that we are going to be used by using this random forest. And next one is coming to this particular gradient boosting. This is one kind of ensemble learning algorithm, but whenever more predictions or strong predictions required, we will apply. In this case, what exactly? Click-through rate prediction, and it is going to be classified whether a particular click or not click is nothing but whenever through online a particular how many persons are viewed a particular profile and how many persons are not viewed and how many positive information we got as a feedback, how many negative information. So this kind of analysis, this kind of classification we required. Generally we are going to be use gradient boosting algorithms, which is also one kind of classification ensemble learning algorithm. And coming to the next one is instance based and probabilistic models. So in this case, it is going to be rely on distance or calculate the probability of an input belongs to a class. So based upon the probability of a particular class, we are going to be representing the outcome in this model. So the first category and first algorithm we can able to use k nearest neighbors algorithm, KNN algorithm. In this case, instant based or non-parametric algorithm, and it is going to be classify the data points based upon the majority of the class. Is nothing but k1 value we are going to be take nearest to that particular value, how many data points or how many values are associated. Accordingly, we are going to be representing this k nearest neighbor. The name itself having a meaning, nearest neighbor. One point we are going to be take which you are expecting as an outcome, and accordingly how many are relevant to that we are going to be representing in this case. For example, handwritten digit recognition. For example, if you consider this handwritten digit recognition, it is going to be classified based upon the scanned images. So 3 and 8, comparing these two. So what exactly this 3 and 8, what exactly whenever you are writing 3, whenever you are writing 8, so some similarity, some part is there, some is not similarity. Sometimes whenever you are writing or whenever you are taking a sign from multiple persons, so identifying which person's sign belongs to. So this kind of categorization or classification we can perform. So this k nearest neighbor algorithm. And next one is Navi-Bayes. It is a probabilistic approach classification based upon the Bayes theorem. So in this case, basically the example which we can able to take, document the classification, like if a news article belongs to the which category. Generally, if you consider the news, so several categories like politics category and sports and education, and also you can able to represent a finance category. So which category news, if you want to classify with respect to the requirements, so there we are going to be use this Navi-Bayes. And what exactly the probability, how many days, for example, some newspaper for every weekly once some kind of specific information they are going to be published. So what kind of information is nothing but the probability also we can able to represent. This particular sports information, these many times will be published in so and so newspaper per week. So this kind of classification also we can perform by using Navi-Bayes. And coming to the example, in this case, I am demonstrating for a support vector machine by using Irish dataset. So in this case, whenever you are considering that particular libraries, some NumPy as well as Matplotlib and scikit-learn library I have using in order to representing the dataset and a support vector machine as well as to perform splitting operation of a data set into training as well as testing. So here we are taking this particular step. First one is we have to load the iris data sets. And step 2 is we are going to be split the data into training as well as testing. What is the percentage of training data sets and what is the percent of testing data set. So coming to the loading data set, already I am going to be imported that particular data set by using scikit-learn, and from there I am directly importing, I am calling that load iris, and I am going to be representing with respect to x as well as y. And what is the target output? What is the input we are taking through the x as well as y. And coming to the splitting, here already I represented the testing data set 20% I have given, that is 0.2 I have given, and 80% is training data set. And coming to this particular model, here we are going to be representing what model we are applying on trained as well as testing data sets as per the requirement. The model which you are applying, that is a SVM model we are representing, what kind of type it is? Linear. The linear SVM we are going to be considering, and now we are going to be fitting that particular data which we have trained as well as tested, and then after that we are going to be performing the matrix calculation. And in this case, what exactly you are going to be representing? The sepal length as well as width. Based upon that, how we are going to be representing? See here. In the outcome, if you consider, so that particular hyperplane with the distance bars of an iris data set we are using. So based upon the width as well as length categories, so and which one belongs to which category and what exactly this is the hyperplane generally. So based upon that, which components are near to that particular, which category we are classifying. So this is the representation of support vector machine through hyperplane methodology. And here one more also we have taken logistic regression. The logistic regression is a first classification technique in the machine learning. So generally logistic regression we are going to be used by using a sigmoid function to classify whether the outcome is belongs to positive or negative or 0 or 1. Okay, maximum outcome in between 0 or 1 it will vary. Okay, and in this case we are also representing some performance metrics like precision, recall and F1 score and supports. And whenever you are taking the components of this particular accuracy point of view and a precision recall point of view, accuracy always will be represented total number of positive outcomes by total number of outcomes. And like that we are going to be take precision recall. In order to represent this model we are going to be use this logistic regression. And in this case if you observe majorly, so always we are taking that what kind of linear one we are taking from the logistic regression, and we are going to be predicting that particular model and what kind of way we are going to be representing from the data set. Some data set we are importing, and after that we are going to be use this confusion matrix. Based upon the confusion matrix, the model is going to be representing in this particular parameters. And after that we are fitting that particular model, and you are finding that particular model how it is going to be representing in the form of confusion matrix in order to evaluate each and every parameter of a particular model as per the requirement by using SVM. So in this case we will observe all these particular matrix calculation, and we can able to find out which one is the best and suitable one. And coming to the summary of differences among this classification as well as regression. In this case, the following features I am considering in the form of to differentiate classification and regression. First one is output type. Next one is goal and example and algorithms. Coming to the classification, as we earlier discussed in the previous slide, classification is nothing but a discrete model through labels we can able to use, and regression is nothing but continuation quantity in the form of numbers. Prediction point of view we will use regression. And goal is nothing but find a decision boundary, like in the previous algorithm. If you see some decision boundary we have given through a hyperplane, and from there we are going to be representing how many clauses are belongs to which category, falls under which type. So like that we are going to be used in the classification. Regression is nothing but find a best line or best fit. In the previous example, we are going to be predicting a particular person's salary based upon his experience. Through training data set and testing data set also we have shown through diagrammatically. And example also we can take with respect to classification. So a particular picture is a cat or dog, or what kind of object it is, such kind of classification. And even with respect to fruits also, what kind of fruit it is, apple, pineapple and some cherries are there, which comes under which category, this kind of classification. And some more examples also we can take. Some several balls are there. Okay, basketball, football, cricket ball, volleyball. Okay, based upon the size and dimensions, radius, we are going to be classify which ball comes under which category. So it is also we are going to be representing through this classification. And in this case, coming to the regression example, we can take so many like house price prediction and particular stock prediction, like that we can take. And algorithms as per what exactly we discussed is support vector machine, decision entries, logistic regression, and so on we can take for the classification. And the regression point of view, so many what exactly we discussed, but few things I have represented: linear regression, polynomial regression, and so on. And coming to the machine learning applications, so in this case, the machine learning basically which will be used in different domains as per the requirement, but which will be used in the real more popularly that I have used. First one is recognizing the patterns and generating the patterns and recognizing the anomalies and predicting the particular required outcome. So coming to the recognizing patterns, so facial recognition. Based upon the expressions, we have to identify specific faces. And next one is handwritten or spoken words and medical images. So with respect to different domains, we are going to be recognizing the patterns. And next one is generating pattern. And here we are going to be looking into it, how we can able to generate the images and what exactly motion of an image based upon a specific time. So that is also we are going to be used. And the next one is recognizing anomalies. So in this case, credit card transactions, and next one is the some patterns with respect to nuclear power plant, how it is going to be representing. So all this kind of recognition we can able to perform, and predictions, future stock prices or currency exchange rates. So all these kind of predictions we can able to represent as a part of machine learning algorithm. And machine learning applications with respect to industry, if you talk in the healthcare domain, finance domain, and retail domain, and transport domain, and social media, agriculture, in the different domains with respect to industry, we can able to represent over here. So with respect to each and every domain, I have given what exactly the use case of each and every domain. If you consider healthcare, diagnostic or else drug discovery, basically that is the main objective in the healthcare domain. Example, you can take some cancer detection, and finance also, fraud detection. So whenever some person took a loan or you applied loan, whether the person is really genuine or fake, what kind of his history, background, everything we can able to perform. So, and whenever you are performing some transaction, whether it is authorized person or else unauthorized person, and what kind of way he performed, like some several types, either card or else some PayPal, different transactions, what it is, what kind of way, and the transaction which is performed genuine or fake. So that is also we can able to use with respect to financial domain. And next one is retail, is nothing but recommendation. Generally you are already aware about recommendation system. So if you take Flipkart or Amazon, whenever you want to purchase a specific object into that particular Flipkart or Amazon, or later you are thinking that later let me purchase. So in that case, what happened, whenever some discount or some kind of as per your requirement, if it is fall down the price, then automatically you will have a recommendation stating that please purchase, because as per your requirement that amount was decreased with respect to specific item. So that is called generally recommendation system. And as well as one more example I have given, Netflix, Amazon. Okay, so this is also best example whenever you are watching movies or your interest movie. For example, horror movies or comedy movies, you are interested to watch, every time you used to watch. So such kind of certain category movies are just uploaded, you are going to get notification stating that your interested movies are just uploaded, you are ready for view. And next one is transport. So autonomous driving, so like Tesla and Waymo, so many other different sources we can use. And social media, so content feeds and by like Instagram, TikTok, so many real world applications we can able to consider in order to represent the social media. And in the form of agriculture also, so crop monitoring, what kind of crop detection, and next one is what kind of disease, if it is having what kind of disease, and in future what exactly the healthy crop, and all these things we can able to represent through this particular machine learning applications. So thank you for giving me an opportunity. Thank you.